Good morning, everyone. Thank you so much for joining us today. I hope everyone is doing well. My name is Victoria, and I'm a Senior Business Development Coordinator at 2H Offshore. With many industry events and conferences canceled due to COVID-19, we've put together this series of live webinars to keep our valued clients and colleagues up to date on the latest happenings in the world of riser and conductor engineering. I want to welcome you all to our webinar today entitled How to Extend Field Life and Decrease Costs by Enabling Flexible Pipe Reuse. Before we get started, I'd like to cover a few important housekeeping items. Firstly, this webinar is being recorded and will be made available to you soon, so please look out for a link to that in your email. Secondly, if you have technical or content-related questions today, please feel free to ask them at any time. You can use the Q&A box that is located on the right-hand side of your screen. At the end of the presentation, we will go through as many questions as we can, but if you have further questions, feel free to contact our speaker directly after the presentation. So with that, I'm very happy to introduce our speaker today, Pedro Viana. Pedro is the Flexibles Engineering Manager for 2H in Woking. He has over 16 years of specialist engineering experience of shallow and deep water riser design, verification, and integrity management. He holds extensive experience in a variety of offshore production systems, but in particular, flexible risers design from concept to installation and beyond to life extension. He leads the flexible riser and umbilicals engineering and business development for 2H worldwide and has also authored and presented papers at numerous conferences. He has worked in 2H offices in the UK, Brazil, the US, and Malaysia, having gathered experience in all major offshore oil and gas regions with small and large operators. So with that, I'm going to pass things over to Pedro to get us started.
Okay, thank you, Victoria, for the warm introduction. I am very excited to be here today, speaking to you about this topic and sharing our experience and views. I guess the record number we have of attendees today tell us that this topic indeed raised a lot of interest out there. So hope the information is useful for you all and looking forward to the questions at the end. So let's get started talking about flexible pipe reuse. But before I start, I will actually go it in a slightly unusual way. And I will start with an analogy with an industry that explores the reuse of an asset, perhaps to all its extent. And that will help us get thinking and see the possibilities we have with flexible pipe or even in the oil and gas industry. Okay, so when you look actually for a new pipe or even the same way for a new car, why don't we always just get a brand new one, right? Of course, it's shiny, new, latest technology, but it's expensive, definitely. And sometimes, even being new, it still brings some unknown issues that we need to be aware of. Okay, so then what if we get a used asset, right? Of course, the major benefits we are talking is about the cost saving. And perhaps not just the direct cost, but perhaps the arrangements you have, like lease, rent, but okay, you decide to get one. But then comes what the concern. It always brings the concern about the integrity and reliability. And we address that through monitoring, over the life of the car in that case, or continuous inspection, by an authorized vendor, by someone, a specialist, right? It's not just a need sometimes or a nice to have, but when you can, you also want the vendor, an approved vendor at least to get involved, or at least to have the quality stamp of that specialist. So all of that applies to flexible pipe as well, and sometimes even more that perhaps you don't consider for a car, but I'll be exploring today. It might be an enabler, even for not for a car, to assemble reused parts. So there's a lot of reuse in flexible pipe, as many of you may know, or in the oil and gas industry, with FPSOs and or even subsea equipment. But let's see what's the possibility with pipe that we have today and where we can get to. So today we're going to be covering a little bit of introduction. We have, I'm sure, a vast audience here. So very briefly on the flexible pipes, I'm going to recap some of the key benefits that relate to what we're doing here and some of the key integrity aspects. We'll define what we mean by reuse in all senses, and explore some of those and define, try to highlight also as we go along some of the key opportunities for that. We go step by step on the key steps, actually key phases as well on how to reuse a flexible pipe. And we will review some of the application, the blockers and the enablers. That's when I expect to share some of our opinions, some of the feedback we get from our clients and close with some final remarks, hopefully, or giving a good introduction for your questions at the end. Okay, so let's start introducing the flexible pipe. As most of you should be aware, flexible pipe is composed of multiple layers. We are talking here about unbounded flexible pipes, so they can slide between each other, right? And it's composed of non-metallic layers, as I'm highlighting here, in this image. And those are primarily like the pressure sheet in the outer sheath, polymeric layers that provide the sealing from the bore and the sealing from the external environment, or the tapes, that help keep the metallic layers in place and help reduce the friction between them as well. So on top of that, or between those, we have the metallic layers, the carcass, the pressure armor, the tensile. You can see some of them have a certain profile, and they are interlocked. And I would highlight a few points here, like the tensile armors, they come in pairs, and they are composed of multiple wires. So you have some sort of contingency there if for whatever reason you lose one or more wires. Whereas the pressure armor have only a single wire wound around, wrapped around the structure. And what I'm showing here is more of the typical pipe, and perhaps more the typical even for a riser. But for some other flexible pipe, like for flow lines or jumpers, you may not have the carcass, or you may not have the pressure armor, depending on your actual conditions, your pressure or even the fluids. You're talking about either gas or water, etc. Right. So all these layers need to be terminated and sealed as required at the end. And since the beginning, it's still a manual process. And of course, it's quite a critical component than the end termination. So moving on, let's talk about a few of the key benefits, of the design aspects. Sorry, for the flexible pipe. It's, as I already touched upon, it's very tailor-made, so it's really designed for each application. You define the layers, which can be from 6, 7 layers up to 18, 19 layers, and they suit the specific needs. But they retain a certain degree of versatility. They have excellent fatigue performance, are very compliant, so helps with not just with installation, but operation and adapting on the seabed, when we have some challenge there. They are not just composed of independent layers, but they can also be modular, as the picture I show there to the right. So when you're talking about one flexible pipe as a line, a riser, a flow line, you can actually have that composed of multiple structures. Maybe in some parts of the world, like the North Sea or whatever, you have maybe shallow water. I see many of our clients and the people we talk to are used to a single line, but in some other parts of the world, like Brazil in particular, but wherever you have deep water, you might have a number of structures, and they may be the same or they may be different in terms of the composition of layers. And I think it's important to highlight, flexible pipe, is different from rigid pipe, for example. It's very centralized in terms of supply chain with the flexible vendor. In terms of installation, it's pullable. You can install using reels or carousels. It's the faster type of riser that can be installed, compared to a rigid or a flexible or even a composite. And it's recoverable, and you can reinstall as many times as once. And that's what brings the opportunity that we're discussing here. And when we talk about some of the design, but which relate directly to integrity aspects, I think a few points to highlight there is, as I described in the image below, that's a typical qualification image for a flexible pipe, where it's limited by the diameter, the sizes, right? The diameter and the pressure, the water depth or the design pressure in terms of internal pressure. But the pressure and the temperature also define very strict envelopes for the materials. So all those non-metallic layers depend a lot on that. So that's a key point to retain attention. And historically, there's of course been a lot of learning with understanding even better those limits and effects, not just of pressure and temperature, but even the fluids you have inside, how they affect those polymeric layers, right? So I think it's fair to say, I'm someone who, of course, who loves flexible pipe, but I think it's fair to say flexibles are very sensitive to damage, right? Integrity is always a term that comes with flexible pipe. But the same way, perhaps it might be relatively easy to damage a flexible pipe compared to a rigid one, especially the outer sheath. You can also repair a flexible pipe, what in many cases wouldn't be possible with a rigid. So I think that's also a great advantage and counterbalance the problem. Okay, so that links me to actually the integrity aspects, exploring a bit more. What I have here to the right comes from the SureFlex GIP, and that's is a lot of data from different years, and I'm not going to go into detail, right? But I have actually grouped those in the left here in some of the key aspects as we see, right? So I think it's important you understand some of those potential integrity issues are related. And so if you go along, so some are design manufacturing, as I said in the beginning, even a new asset, even a new car or a new pipe can come with problems, right? So a used pipe, actually, you may already know the problems that are there. We have some non-conformities. A critical time is the installation time. So that's often when a lot of the issues start or happen, but transport during the whole transport and installation until you get it in the operational condition. And once you get it installed, then from the installation time, but then of course during operation, strength and fatigue, the overstress and the long-term performance, and that links to the actual operational conditions, because a flexible pipe manual will define the correct operation, but I'm sure most of you must have experienced situations when you use the pipe beyond its original limitations, being aware or not, right? So being higher pressure or anything in that sense. And in particular, if you change the fluids, that can also be that can cause like material degradation, and even if within the standard limitation, you may have problems. Right? So I would highlight some of those as potentially somewhat hidden degradations, because some degradation, some overstress, for example, may just take your pipe down and you will see it. Some external sheet damage will be visible on an inspection. But there are some others which can be somewhat hidden, but it's not a black box. And I'm going to be touching upon ways and methods how we we assess those from design during operation or when you want to extend the life or reuse a flexible pipe. Okay, so a little bit of definition before we go forward. What do we mean by a flexible pipe reuse? Let's start by perhaps the more common or the more strict definition of reuse, right? When you have a full removal and a reinstallation of that line, of that flexible pipe. That's the biggest probably change, and that would usually come together with changing the design conditions. Even if you do on even the same platforms, it may include a degree of changing design conditions, right? The water depth, the environment, so currents and waves, or the platform motions. So whenever you are changing some of those, you may need to reanalyze that pipe, do an engineering assessment to understand if that's okay. Or you may just reuse components. That's perhaps a lot less likely, like in the fittings, but you can find reference where this has been done. Another possibility, a relocation, either moving on the same platform, moving slightly, or moving on the seabed, or making a considerable move, perhaps changing more than you initially planned. So all of this needs to be assessed and may require or not analysis, calculations, or specialist appraisal to the different levels. This has been done, I should mention, since the early days of flexible pipe, especially in Brazil. With Petrobras, they have a lot of experience, relocating, repurposing, using flexible pipe in all sense, and that's definitely one of the key points that promoted the flexible pipe use and has benefited the whole industry, I would say. So if we go on the repurpose, that can just be a changing function. You can change the contents, the pressure, the temperature, so you need to be careful on that. Or I would just highlight there, or you can change from a riser to a flow line or to a jumper, right? So if I highlight that at the bottom there, because in a lot of the opportunities we see for reusing a flexible pipe, we actually, in a certain way, we mitigate the risk or either next known risk or even the unknowns, right, by derating that pipe. So we go from a static to a dynamic, from a dynamic to a static, apologies, like from a riser to a flow line or a jumper, or maybe long for short if you remove a critical section of that line and re-terminate. I'm going to explore that more in a second. Or even if you change the contents, perhaps run a more extreme and dangerous content like oil and gas to perhaps water and service. But in some cases, you also want to reduce the pressure, right? So I indicate there on the picture some of like those different use, the risers dynamic, the flow lines, and the jumpers. But I have actually selected that picture for a purpose. That's an emblematic case. Now you can find that reference to that in the public domain. So that was the Shelley FPSO, Shelley Fields, that operated in 2009 until 2010, if I'm not mistaken, in the North Sea by Premier Oil. But within 1 year from the operation, they found it had poor economics, and they decided to decommission the field. So the decommission program included a lot of removal of the pipe to be reused, and they have actually sold the riser, the buoyancy modules, clamp weights to others, to third parties. I'm not sure if other operators or how. Although some of the jumpers and some of the equipment was not reused, and even the end fitting in that case, for example, was stored to potential layer reuse. Okay, reuse, perhaps if you expand that further, can also mean bringing back to service, right? So if you have a damaged line, that's no use, right? So if you need to repair and bring back to service, and that may include different tests, different types of inspection, or a whole new evaluation, as if we're doing any sort of other previous options of reuse, right? Apologies. So that also includes perhaps the line life extension, because that will bring the pipe beyond its original design life, right? So if you extend the life, actually you had a predicted damage, that's a fatigue damage, and you want to extend. So that's also reuse. So as I mentioned earlier, right, just to highlight here some examples and give a little bit of an image for you, a flexible pipe, yes, and a flexible pipe in operation can be damaged. Perhaps that's an example where a flexible pipe that was in operation was damaged when they were pulling in an adjacent line, but you didn't lose that line. You could take the opportunity that the vessel was out there, bring it to the installation vessel, repair, have it fully operational, and just continue. So you didn't let it propagate and accumulate the damage. But in another way, often, especially like for risers, the top section is a critical one. It's fatigue critical, while the whole line might have a lot of fatigue life still there. So one option, as I described here, is to re-terminate the line offshore. Again, though, there are numerous examples, and Petrobras has done that a lot in Brazil, has a lot of experience there. But you will see that being mentioned in JIPs, and that has been done in many cases. We have been involved in a few in the last few years. There's some publications out there. And you can do that in different ways. What I should describe here is generally like when you need to cut off, let's say, a problematic section, maybe come up with a new section only while we are reusing the whole external section. But in some cases, you may just remove 15, 20 meters of the top section and re-terminate offshore and keep producing, right? This can be done offshore or in different cases as well. Okay, and then let's explore that a bit more on the key benefits of reuse, right? I started with the analogy of like the benefits of reducing costs. Yes, definitely, but in many sense, right? First, you're talking about hardware and procurement costs. Yep. But there's also a great potential on lead time reduction, and really depends on what application you are thinking of on your reuse. And I'm sure all operators have a number of possible applications for reuse in their pipes if they start to think and they start to plan properly. Right? You may anticipate a new line operation, in particular where you have you just need one line for a tieback or a marginal field, or even if you have a failure of a full line, right? It may allow you a rapid replacement. Perhaps you have a news line or a line in the same platform that's not in operation. If you already have the plans in place to keep that as a spare line, that can save a lot of time and cost and revenue. Or it may help you anticipate the first oil, right, on a new platform, or even be used on extended well tests. So all this is considered, is done out there, but I'm sure it could be done a lot more. So I illustrate that with a very high level schedule here, showing like what would be in a schedule I'm sure we can deliver flexible pipe, from a PO time, include the design until installation starts in less time than that. And that's why I put that light blue for the qualification and how much you need that before you actually come to the manufacturer. So, but using that as a comparison with hypothetical case with a reuse pipe where we really need to recover and bring for onshore works, which is not always the case. I will come to that. But you can do your early planning while the line perhaps is still there, and when you actually have your engineering approval, it's pretty much now moving to the recovery or any kind of onshore works needed and straight to installation. So there's a lot of time that can be saved there. And if we extend those benefits further, I already touched upon life extension, right? And in many cases, reuse is really like what will enable your life extension, because often when you extend the field, the life of a field, you probably only need, well, you're trying to achieve only a few more years, which wouldn't make it cost effective to make a whole new pipe, and especially if you need a few pipes, etc. So you can move perhaps your assets around and optimize using the lines you have and ensure a little bit more depletion of your reservoir. So it may depend, of course, on the those to actually be viable, as I said. So and it's a continuous process, right? I mean, of course, I could keep mentioning Petrobras because they do that and they benefit of that. But any operator, even a small operator, I'm sure has a lot of opportunities to think about the scale. You may be reusing one line, but if you plan ahead, you can optimize your offshore operations if you need either to retrieve that line or if you just need to move, and you can then bring some scale benefits, right, and optimize the work you're doing. And I think that's also very important. That provides a lot of empirical learning because you learn from removing your lines and evaluating, reusing how much perhaps other lines can go to the same process. Moving on. Okay, so we discuss a lot about the pros and the benefits, right? And let's see, how do we achieve that? How do we go on a step by step to make reuse a reality? We have a phased approach proposed here, and the way we organize that and is slightly. I don't think you can find in anywhere else. I mean, it's pretty much how I have come up with, and although you can find a lot of guidance in the industry documentation like JIPs and APIs out there, but the phase one and phase two, they are essentially your early engineering assessment, and then that continues with your historical data gathering and evaluation. So that's essentially a desktop assessment, right? That's paperwork, but it's quite critical, quite important, and quite important that you start that early on because that could extend. You may need more or less time for that. And whereas phase three is when you really go to as needed, offshore recovery and onshore inspection, management, and repair works, offshore or onshore as needed. And then any testing that you may need and the offshore installation. Let's go phase by phase. So, okay, phase one, although it may sound a bit obvious, it's very important, just like in a new design, that to start by establishing your clear objectives, right? The objective is pretty much, defining your specifications, your scope of work, just like a new pipe, because those will drive the feasibility of your reuse, and you actually may at any time go back and perhaps reestablish those objectives, right? What's your functional requirements, operational, and material requirements, because they will drive then the continuation of your assessment. Okay, so with those objectives defined, then it's really like understanding what's possible with that line. So you need to understand the design limitations. You may have some very old pipes, like the example data sheet I could dig out there from 93, right? Or you may just not find those information. But ideally, you would like to have all design, fabrication, installation documents, right? Key point is to pay attention to code changes. A lot of those old lines will have been designed for old codes, so you may need to ensure they're also suitable for the new codes or to which extent they are. So that's not a showstopper, but that's a potential limitation. So you go through your general design review, and that should start early on, but that will continue throughout the next phase, and I will come back to some of these points, right? In particular, you review design characteristics, anything that may have affected that pipe, And although you start with your preliminary like design paperwork and whatever you have, you may come back to it when you look into the historical one in historical aspects in the next phase. And you need to consider new installation conditions, new in-place conditions, potential degradation. No, there might be a lot more learning there is a lot more learning in the industry about potential failure modes. So you may need to look back, even the design may not to points which even the design may not have accounted for. And assessing the remaining pipe service life, that's one of the potential black box of fatigue, and now you explore that in a second as well. And with that, you define whether the riser is fit for, or the flexible pipe now is fit for the new service. Great, so you've done the initial assessment, so comes to a very important one and potentially very time-consuming one, which is the historical data gathering, right? Because detailed records is something that everybody would like to have and very organized, but it can vary a lot per operator, per asset, per field, and how accurate it is. It's really a case by case, right? But even regardless of what you have, if you have a very detailed and comprehensive integrity management process, that's a time, better later than never, right? To gather and gather data, assess potential failure mechanisms, and perform that based on those you perform your risk assessment. So the same way you could do throughout the life of the field and define your risk-based inspections, you should do with, of course, a different objective, when you come to reuse. And as I mentioned, right, that must include all phase and perhaps even like once if you are retrieving the line, that we must also account for that. And when you're talking about those record data, for example, key ones I indicate here, for example, like the anomalous testing over the life of the riser. That's quite common these days, but any kind of monitoring or inspection data can be very valuable at that time. But even if you haven't had any of that during the life, it doesn't mean the riser cannot be used. I'm sure you have operational data like pressure and temperature from your fluids, or you can also have ad hoc perhaps inspection at the end or at the end of the life prior to reuse decisions. Okay, so I'm coming back to my start point from early on. So how can you define if that line, that flexible pipe still has a life available, right? Because you will do as original design and assessments on the fatigue life of the flexible pipe. But once it has been in place for a few years or many years, you can reassess that at any point, using your original method data, design data, or any improvement on this data that you may have, right? And you can do your global and your local stress analysis. That can be done independently, and that's one aspect I would highlight where in the last years there was a lot of development in the industry. You have a few independent players who can provide that, and with commercially available softwares like BFlex, the one we use. But in any case, that will provide an assessment, a stress histogram, and at that point in time, you define whether you can actually extend your original design life or not. But doing that continuously is a challenge, right? The FAA does one-off assessments. An alternative way it's also possible, right? It's using monitoring. So maybe if you're having sort of motion monitoring, bending monitoring on your pipe, that may just improve your prediction. Where you replace your metallurgical bike measurements, your motions, replace your global and local analysis by a machine learning model, a digital twin. And because you bypass that computational effort, can have a real-time stress, time history, and your cumulative damage. So that's something that you can have as part of an integrity management program, or something you can retrospectively assess before any decision to extend the life and reuse a pipe. Just to highlight, we actually describe that in a lot more detail in ISOP conference, which is happening virtually in a few days' time. Okay, so you've gone to phase 1 and 2. You concluded that's possible. Yeah, let's move ahead. Let's reuse this pipe. At least let's go to the investment and let's go to a pipe retrieval if required, right? You may not always need to bring back the pipe on shore. And ideally, of course, if you would avoid that if you want and save transportation time costs. But if you do, No, you need to ensure the preservation of the pipe during and after the recovery. So that requires careful planning. It's not just like the same you do during a normal decommissioning. And the installation, in a way, is a reverse of the original installation. But you need to account for the actual in-place conditions, how the pipe actually is, it may be buried, and often you would expect higher loads during the recovery of the pipe than you would have in initial installation because you have potential additional friction due to marine growth and the restrictions from the soil as well. So you need to assess the structural capacity, your proper analysis, and also account for the annulus condition, which may be pressurized. So maybe your recovery speed rate needs to be slow enough to let your annulus balance and vent as required. So there's a lot of little details you need to pay attention to. But as I said, API and industry guidance is available there to provide some reference, and so are we, right? So we need special care with marine low temperatures and polymers because they may be particularly low temperature in many cases, and when you're doing that needs to be assessed, perhaps what's different from the original installation conditions considered. And now, last but not the least, the health and safety aspects. You need to account. You may have potential radioactive elements, so you may need to ensure you clear those upfront. And those rises either recovered on shore or they can be wet parked. And wet parking is something that can be before any new installation, but it's definitely possible. It's done a lot, but the actual conditions or how long and what kind of fluid you may want to have in the bore to ensure your preservation, you have to account for the pipe materials and also how long you expect to leave that pipe down the seabed. Moving on. So either whether you recover that pipe to shore or not, and you will have the opportunity to inspect that pipe, even if it's offshore. As I mentioned, like another point perhaps, that's where there was a lot of improvements over the years was in the pipe inspection. So there's a lot of new tools and methods, which you can use and keep improving. There's still, I think, a lot of development to go, but they do provide a lot of additional information if you need, especially when you're going for a special case of reuse, right? When you're going for a new service, if you're changing considerably design conditions, you really want to ensure you have a proper condition evaluation, right? I highlight also another point, which perhaps is I could say a technical advance, sorry, with the dissection, right? Dissection of a flexible pipe is not something new, and something that's probably historically was a lot more done as a root cause investigation. But if for any reason you have a piece of a flexible pipe, you can also use that as an inspection, right? Because as the example I mentioned earlier, if you reterminate a flexible pipe, maybe you can take that section and use that to investigate and ensure you have a pretty good detailed assessment of the layers. So there's expertise not just with the vendors. There's a lot of expertise within the design house. We have taken part of those. That's an example there. Or any of the labs, companies like TWI and SINTEF, they have helped us a lot on those. So there's a lot of experience out there. And in your dissection, if there is an opportunity, that's once you have recovered the pipe and brought to shore, that's quite a cost if you need to do this. But dissecting the pipe is probably relative than a low cost, perhaps lower than you expect. Of course, that can grow, and perhaps that can take a lot of time if you decide to go into material testing, the polymers, or like a fatigue testing, as the example we show there on a paper we published in OTC last year. But a key point is that it can be quite a considerable key risk mitigation. And in some cases, because you're testing your actual pipe, if you are continue to use a section of that pipe, that may even allow some reduction in safety factors. But if you need to do any maintenance or repair on a pipe, that's a key point where you need the vendor, right? You want whatever one of the key flexible vendors to take care of their own pipe if there is a repair need. And that includes the retermination, because as I mentioned before, maybe summarizing here, the retermination of a pipe, a riser or a flow line, that can be a requirement because that section was not good for use anymore, fatigue or has a damage, or maybe just because you need to cut the pipe to a certain length. or it can be just a risk mitigation, removal of a critical section because you just cannot quantify, or you want just to be sure you have the best pipe you need. But that will give you the opportunity for dissection. That's the great point. Okay, phase 4 and the last phase, with whatever new application you're gonna have. So you want to test your pipe, and the testing of the pipe will be as per the latest codes, even if originally it was not. Not the same code, right? And you will do your hydro test, and that doesn't necessarily need to be done onshore, right? That's done and we have taken part on that. That can be done after repair or before reuse offshore. And if you need to downgrade your pipe, you will go. You can still go to 0.67 of the pressure that you actually test. So that's perhaps is something you can consider as well. And and then proceed to reinstallation, as I said, also following the codes and your actual reuse of application. Okay, so let's go for a quick review of the application, the blockers, and the neighbors now that we know how to reuse. So that's, as I said, covers a lot of feedback and our own research and experience around the world, right? I already mentioned, and I think I do find some reference, although I don't find like papers, etc. Coming from Brazil, everybody talks about flexible pipe reuse. We know there's a lot of pipe stored onshore and a lot offshore, and Petrobras applies that, left, right, and center, and since the early days of flexible pipe. So that's a great benefit, and it shouldn't. And a lot of the operators we talk to think that that's only Petrobras because because of the scale. But I hope that presentation helps indicate that no. So outside Brazil, you do see a lot of reuse in other senses, although there's all the full reuse, right? And I mentioned some examples there. That's quite common, I would say. Repurpose, changing perhaps a function, or changing the conditions, perhaps increasing your pressure, and then you maybe need to reassess your fatigue condition, things like that. But there's definitely a perceived and a negative perception, right, in the cost and risk associated with reuse. And I think that's the main blocker, because that often stops the process upfront. So we probably discuss reuse every year, or at least once a year. And it's very few cases when it actually does happen, especially abroad and outside Brazil, as I mentioned, right? But the way we propose, right, to break in phase it's really like to address that and ensure you define your decision gates, and you can take some costs and or even like understands how you can mitigate the risk and what's actually the cost of the risk, to address that as much as you need with monitoring or whatever. So so that's also related to the flexible pipe integrity, which is a major concern, and we often hear that many clients, many operators out there thinking that flexible pipe, it's a bit of a black box. I think that's not the right understanding. Of course, in some sense it may be, but we have tools, we have independent companies. Of course, we have the vendors; they are very valuable, and you can ask that, and you should involve them in that discussion. But there are different ways whenever you have a doubt of being a black box situation that you can break through that and get your confidence, and get expert advice to move on. So the lack of warranty, I think that's something that can be worked around. We don't have a warranty for everything you have out there, and usually that's 1 year. But you have your insurance, but they can still be some potential blocks. You need to address those. And I mentioned one point that I explored a lot about retermination, because I see a lot of also negative perception and a blocking view on those, and I think that's a cost, and that's not something necessarily you want to do, right? But when you can do this for other reasons, that brings a lot of opportunities, and that has been done. And perhaps the more people do, the more people in the industry out there internationally will have the experience and the confidence in doing. So already touched upon, but if you go to a few of the enablers, I will jump over the phase approach. I think I explored that enough. Now I would just highlight my second bullet there. I think of course, an integrity management process can pay back during the field life, but if you are an operator, if you think ahead, that can even take into account the potential or the known future reuse of a flexible pipe. So definitely vendor support can help that, and vendors do provide that test and storage. They provide client support, general integrity support. But if they got further involved, perhaps they could help even more, right? There's a question mark there on the warranty, or even providing some flexible riser lease. Maybe not just with the vendors. We have discussed that possibility of flexible riser lease with different, let's say, industry players, but I haven't seen that yet, being executed. So um, I mentioned that already as well. So I think a key point in the neighbor now, for those who didn't consider much of the reuse of pipe is the improved capability and experience of tools and independent components and the methods we can use, right? But if you take all those points discussed today here forward, we should also think, I think the whole industry could benefit of a good balance between standardization and innovation, right? Because of course it's good that you have one pipe tailor made for each occasion, but having some standardization that could also be used across the industry, across some fields, etc., would help with time, but will help with the reuse and the general understanding of the issues, like not bringing a new pipe with a new material that will bring us a new potential failure mode in a few years, right? And in that sense, all like, could you design for reuse? I have seen some presentations that in the past, but I think for me, that also touched upon what I mentioned about intermediate connections. It's something that you avoid if you can, but if there is a benefit there, you also bring an additional benefit like reusing those sections and avoid have to re-terminate, facilitate removal of critical sections. So there's a benefit in place, but also in the extent of the life. Great. So a long talk, but I'm coming to my final remarks and I get straight to it. So I think there's a great opportunity, especially in times like now. I mean, times of downturn when people are looking into saving costs and extending life, and maximizing, the field depletion, right? But that comes together also with the amount of flexible pipe we have out there, right? We all know there's a lot of decommissioning going on, or a lot of decommissioning plans for the North Sea. So, and that's a key region outside Brazil with a lot of old flexible pipes. So definitely an opportunity for reusing, not just around there, but perhaps even in other locations. So the maturity and understanding of the flexible pipe within the industry, that brings an opportunity, an enabler, I would say, and just like the improvement of the methods and the general support you can get from the industry. Reuse is done. A lot in Brazil, less outside Brazil, and it's really hard to see. So it'd be great to see also the industry worldwide sharing more of their experience. I hope we are doing some of it and promoting that within the industry further. So definitely that requires specialist understanding. In some cases, also the support from the vendors, right? So you don't necessarily need that, and of course there may be some direct or indirect benefit to them when there is flexible reuse because it promotes the further use of flexible pipe. But nevertheless, we always want to sell a new pipe. But you can find a balance through use of independent companies as well. Key blockers relate to cost and risk, but a lot of this is, I think, is a perceived risk. So it needs the engineering assessment at the beginning is key in ensuring those are well understood and well mitigated. They may not be real, and understand your actual costs and mitigating those as well, planning and executing those. So definitely they could also be further promoted by flexible vendors, but perhaps not just, right? I talked about riser lease, and if you link that back with how it started, with the whole market for used cars, there's no reason why the companies, for example, like the EPCI companies who buy and sell flexible pipe, to the operators, they buy it from the vendors and sell to the operators. Why could they not buy back and sell again, right? Perhaps that's an idea. Also, the different players and even beyond the vendor operators and EPCI companies who could perhaps do that, provide an specialist assessment, and who knows, have a warranty as a game changer. Thank you very much. That takes me to the end of my slides. And I'm glad to hear your questions.
Thank you so much, Pedro. Okay, let's get started doing some questions. Okay, first question. What are the common types of damages in flexible risers and repair methods?
I touched that in the beginning of my presentation, but I would say that probably the most common type of damage on flexible pipe is damage to the outer sheath, right? Because that's relatively um, sensitive, right? So that's damage that happens a lot during installation, but also during operation, because even just a dropped object can cause that. And it really depends on the damage to define what's your repair method, right? If you have a very small, tiny hole, you may just accept that, right? Even if water ingress, but as long as there's not a lot of oxygen recirculation and it's away from the splash zone or critical areas, you may just accept. But there are a lot of methods out there, like where you can put a clamp and isolate that. If it's on the surface, you can even put some tape, some special tapes or wrapping material you can have. And if that's accessible or on the surface, or if you are able, as in the example I have shown, well, to retrieve part of that line and do a full application of the polymeric material and in curing that, then you can have a full sealing. That. So there are a number of methods there, especially for this kind of failure. But I mean, there are others, and for the most common, there will be more than one way to repair.
Okay, thank you. Next question is, where do you see advanced NDT being required in reuse? Pre-removal, post-install, or both?
Advanced non-destructive testing. So not sure exactly which kind of advanced testing you're talking about. I guess probably like the well, if you think about testing as the hydro test is a test, or that's a key one, definitely. When you have any doubts about the ability of your pipe to withstand, loads, because hydro tests you would do you do before any pipe application, but you will do necessarily before you have a new application, right? That's a requirement, and that will bring will make will make it happen any kind of possible hidden damage to your flexible pipe, right? So if your pipe is really in good condition or sufficient condition to operate, it will withstand your hydro test and just be able for the application. I think that perhaps the key one.
Okay, thanks. Next question, does the vendor need to be consulted and is there sign-off needed?
Their sign-off is not necessarily needed. And I'm sure Petrobras, for example, as an example, but also other clients we have worked directly upon, though they haven't necessarily consulted the vendor. Depends on the different types of reuse they have done. When you do your engineering assessment, and we could raise the flag for that, in some cases you need to consult the vendor, right? In some cases you just, if you are, and that often may depend really on the potential issues or the unknowns that you have, right? And that may come, for example, down to the questions related to the materials, especially the polymeric materials. So if you have enough margin there, you might be confident of moving forward without consulting the vendor. If you are close to and tied to your margin, you may want to consult. Of course, that brings if you can talk to the vendor and have the go ahead, is always a plus, right? But you don't necessarily need that.
Okay, next question is, do you have any validated cases using artificial neural networks where you eliminate the analysis by ML model?
We do. Yes, we have a case where we have used some data from sensors on placed offshore on a flexible riser, where or even just not necessarily on the riser, but on the vessel, and you can use that on your models to actually assess the fatigue on the risers. That can be done not just with flexible pipe. We have presented that also on rigid pipe, and that can be done with any kind of similar structure, where you can. And then once you develop your digital twin, so your machine learning model, your artificial neural networks, however you want to call that, then you can actually bypass your finite element analysis and have your fatigue, right? I would maybe highlight that it brings possibilities in terms of like a nearly real-time response, but there might be a case when you actually do want to go back to the FEA, because there will in any kind of modeling, computational assessment, there might be some limitations, and really depends on your results, your margins. You may want to go back to FEA and look in a bit more detail or model something in a bit more precise way.
Okay, next question. Is it common for vendors to warranty the repairs?
I'm a bit confused now. I think I would say no, in some senses. I don't remember specifically hearing about the warranty on the repairs, but I'm sure there is some warranty. I'm sure, I mean, we could go back to them. It may depend on specific occasions. Say, like, for example, if they're installing a pipe and there's a damage, they will repair. And that there is and they're repairing also, like, that's part within their responsibilities, I'm sure, contractually. Well, particularly if they have an EPCI contract, that's an important point, not just an installation contract. But if they are coming to repair a RISE that's already in place, I would expect there's some sort of warranty there, but I wouldn't say it's common. So it's not, to be honest, very clear to me.
Okay, we're going to squeeze in one more question because we're nearly out of time. Is it important that there is measured metocean data available for the original field in order to estimate consumed fatigue?
It's important, but it's not strictly necessary. So again, that will really depend, right? Because let's say it depends to start on how good the original metocean data is, because that's also based on measurements. There's a lot of fields out there, especially around Africa, where we have worked with the original metocean was pretty bad, and then after a few years you have an updated metocean that's completely different, right? And perhaps that's already the one you can use. But even if you use, let's say, the metocean data, that's sort of an input. And if you do then the assessment and your fatigue lives is not sufficient or to extend the life, or it's very narrow line there, then you probably want to have some sort of measure data, because that actually will help you reduce the conservatism and then perhaps benefit from that. That's when there will be variable. That can be either maybe a more specific metocean measurement, can be perhaps a motion measurement, or anything that can help you further benchmark either what you have or use as a base for reducing the conservatism on that part of the assumption.
Okay, perfect. Well, thank you so much, Pedro, for all the information on the topic. This is all the time that we have for today. As we mentioned earlier, if we didn't get to your question or if you'd like to continue this discussion, you can contact Pedro directly using the details provided here. Thank you to our audience for your time and participation. We hope you all found this useful and will join us for more webinars in this series happening every 2 weeks during our time at home. Our next webinar will take place on October 21st, and the topic will be Addressing Integrity Issues on Aging Platform Conductors. You can see more details and sign up on the 2H website. And again, please look out for the recording of this webinar in your email in the next 24 hours, and we hope you all enjoy the rest of your day. Thank you.
Thank you, everyone, for the participation.